show you how to solve the problem or equation that I've made in every topic, which is the derivative of logarithmic function, trigonometric function, exponential function, and maxima and minima problem. So first, we have here an example of derivative of logarithmic function, which is our equation is y is equal to log to the base 5 of quantity x times x plus 4. So before we derive this problem, we need to simplify it first by using the product rule of logarithm. So it will become log to the base 5 of x plus log to the base 5 of quantity x plus 4. So after simplifying, we can already derive this problem. So in order to derive this problem, we're going to use the sum and difference rule, which is the u derivatives plus v derivatives, which is our u is this and our v is this. So our y prime, or our y derivative will become 1 over ln of 5 times the quantity of 1 over x times 1 plus 1 over ln of 5 times the quantity of 1 over x plus 4 times 1. So this is the derivative of log to the base 5 of x, and this is the derivative of log to the base 5 of quantity x plus 4. And after that, let's simplify this. So it will become 1 over ln of 5 times 1 over x times 1 will become 1 over x ln of 5 plus 1 over ln of 5 times 1 over x plus 4 times 1 will become 1 over x plus 4 ln of 5. Then let's simplify this. To simplify this equation, we need to get the least common multiple of our denominator, which is the least common multiple is x ln of 5 quantity x plus 4. So it will become the denominator of our problem. X ln of 5 quantity x plus 4 plus over x ln of 5 times x plus 4. And then x ln of 5 times quantity x plus 4 divided by x ln of 5 times 1 will become x plus 4. Then plus x ln of 5 times quantity x plus 4 divided by quantity x plus 4 ln of 5 times 1 will become x. And then because our denominator is equal, so let's combine the fraction. So it will become x plus 4 plus x over x ln of 5 times quantity x plus 4. Then let's combine like terms. So x plus x is equal to 2x plus 4 over x ln of 5 quantity x plus 4. So now this is our answer. So this is the derivative of log to the base 5 of x plus log to the base 5 of quantity x plus 4. And now, we have here an example of derivative of trigonometric function, which is our equation is y is equal to sin x over 2 minus 3 cos x. So because our equation is a fraction, we need to use the quotient rule to derive this problem, which is the quotient rule is f derivatives times g plus g derivatives times f over g squared, which is our f is our numerator and our g is the denominator. Then, let's solve the derivative of this problem. So it will become y prime or y derivative is equal to derivative of sin x is cos x times our g, which is 2 minus 3 cos x minus the derivative of 2 minus 3 cos x, which will become negative 3 times negative sin x times sin x over, which is our g is 2 minus 3 cos x. It will become 2 minus 3 cos x squared. So, let's simplify. It will become cos x times 2 will become 2 cos x. Then cos x times negative 3 cos x will become negative 3 cos squared x minus negative 3 times negative sin x will become positive 3 sin x times sin x will become positive 3 sin squared x. When distribute, the negative value will become negative 3 sin squared x over 2 minus 3 cos x quantity squared. Then, let's see if there's a common. So, we can see there's a common between negative 3 cos x squared x minus 3 sin squared x. So, it will become 2 cos x minus 3 quantity cos squared x plus sin squared x. Just remember that cos squared x plus sin squared x is equal to 1 over 2 minus 3 cos x quantity squared. So it will become 2 cos x minus 3 times 1 because the cos squared x plus sin squared x is equal to 1 over 2 minus 3 cos x quantity squared. Then 2 cos x minus 3 times 1 will become 2 cos x minus 3 over 2 minus 3 cos x quantity squared. So this is our y prime or our y derivative, which is the derivative of y is equal to sin x over 2 minus 3 cos x is 2 cos x minus 3 over 2 minus 3 cos x quantity squared. And now we have here an example of derivative of exponential function, which is our equation is y is equal to e to the power of negative 4x squared over e to the power of x squared minus 1. So, in order to derive this problem, we need to use the quotient rule, which is f derivatives times g plus g derivatives times f over g squared, which is our f is the numerator and our g is the denominator. So, let's derive this equation. So, y prime or y derivative is equal to the derivative of e to the power of negative 4x squared, which is e to the power of negative 4x squared times negative 8x times our g, which is e to the power of x squared minus 1 minus the derivative of e to the power of x squared minus 1, which is e to the power of x squared times 2x times e to the power of negative 4x squared over our g squared is equal to e to the power of x squared minus 1 quantity squared. And then let's simplify. It equal to e to the power of negative 4x squared times negative 8x will become negative 8x e to the power of negative 4x squared times the quantity of e to the power of x squared minus 1 minus e to the power of x squared times 2x will become 2x e to the power of x squared times quantity e to the power of negative 4x squared over e to the power of x squared minus 1 quantity squared. Then let's simplify. Negative 8x e to the power of negative 4x squared multiply to e to the power of x squared minus 1. So it will become negative 8x e to the power of negative 3x squared plus, because negative times negative will become positive, 8x e to the power of negative 4x squared. Then 2x e to the power of x squared times e to the power of negative 4x squared will become positive 2x e to the power of negative 3x squared. Then distribute the negative sign, it will become negative 2x e to the power of negative 3x squared over e to the power of x squared minus 1 quantity squared. And then, let's combine like terms. So, negative 8x e to the power of negative 3x squared minus 2x e to the power of negative 3x squared will become negative 10x e to the power of negative 3x squared plus 8x e to the power of negative 4x squared over e to the power of x squared minus 1 quantity squared. So this is our y prime, or this is the derivative of our equation, which is y is equal to e to the power of negative 4x squared over e to the power of x squared minus 1. So we have here an example of maxima and minima problem. So our problem is find the maximum and minimum value of a function which is 2x cubed plus 3x squared minus 12x plus 3. So let f of x is equal to x cubed plus 3x squared minus 12x plus 3. And after that, let's get the derivative of this function. So, the derivative of this function will become 2 times 3x squared plus 3 times 2x minus 12. Then let's simplify. It will become 2 times 3x squared will become 6x squared plus 3 times 2x will become 6x, then minus 12. And this is our first derivative. And after that, let's equate this derivative to 0. So, the derivative of f of x is equal to 0. So, it will become 6x squared plus 6x minus 12 is equal to 0. And after that, let's see if there's a common. So, common there is 6. So, divided by 6. So, it will become x squared plus x minus 2 is equal to 0. So, let's factor. It will become x minus 1 times x plus 2 is equal to 0. Then, x is equal to 1 and x is equal to negative 2. And after that, let's get the second derivative. So our first derivative is equal to 6x squared plus 6x minus 12. So our second derivative will become 6 times 2x plus 6. Then let's simplify. 6 times 2x will become 12x plus 6. So this is our second derivative. So let's put x is equal to 1 in our second derivative, which is 12 times x, which the value of our x is 1, plus 6. Then let's simplify. 12 times 1 is equal to 12 plus 6. So 12 plus 6 is equal to 18. So 18 is greater than 0. So this is our minimum. So to find the value of minimum value, let's apply x is equal to 1 to the given function, which is the 2x cubed plus 3x squared minus 12x plus 3. So f of x is equal to 2x cubed plus 3x squared minus 12x plus 3. Let's distribute the 1 to the value of our x. So 2 times 1 plus I cube plus 3 times 1 squared minus 12 times 1 plus 3. Then it will become 1 cube is equal to 1. Then times 2 will become 2. Plus 1 squared is equal to 1 times 3 will become 3. Minus 12 times 1 will become 12. Plus 3. Then after that, 2 plus 3 is equal to 5. Minus 12 is equal to negative 7. Negative 7 plus 3 is equal to negative 4. So this is the value of our, this is the minimum value. And then put x is equal to negative 2 to our second derivative, which is 12 times x, which is our x, is equal to negative 2 plus 6. So let's simplify. 12 times negative 2 will become negative 24 plus 6. So negative 24 plus 6 is equal to negative 18. So negative 18 is less than 0. So this is our maximum. And after that, to find the value of to find the maximum value, let's apply x is equal to negative 2 to the given function, which is 2x cubed plus 3x squared minus 12x plus 3. So f of x is equal to 2x cubed plus 3x squared minus 12x plus 3. And let's distribute the value of negative 4 to our x. So 2 times negative 2 cubed plus 3 times negative 2 squared minus 12 times negative 2 plus 3. So it will become negative 2 cubed will become negative 8. So 2 times negative 8 plus 3. Negative 2 squared will become positive 4. Plus, because negative 12 times negative 2 will become positive 24 plus 3. Then negative 8 times 2 will become negative 16 plus 3 times 4 will become 12 plus 24 plus 3, which is negative 16 plus 12 will become negative 4 plus 24 plus 3. So negative 4 plus 24 is equal to 20 plus 3 is equal to 23. So 23 is the maximum value.